this is where you make the hydrogen.
Because you're turning electricity into oxygen and hydrogen, and then from there, hydrogen would wind up going on to power something.
Elon Musk has made a groundbreaking announcement that could redefine the future of both transportation and energy. He has introduced a revolutionary new water-powered engine, an innovation that challenges conventional engine technology and paves the way for an era of environmental sustainability. This development raises several crucial questions. How does this new engine stand out from existing technologies? What impact could it have on global technology and ecology? And what obstacles must be overcome to turn this vision into reality? Musk's revelation came as a surprise to his Twitter followers when he disclosed a major shift in Tesla's direction. After years of skepticism, he announced a transition from battery-powered vehicles to hydrogen fuel. This unexpected decision gained even more attention when he revealed that the first car to use this alternative energy source would be called the Model H. Previously, Musk had been an outspoken critic of hydrogen fuel cells, calling them faux cells and dismissing them as impractical. However, difficulties in the mass production of Tesla's 4680 battery cells led the company to reconsider its strategy, ultimately opting for hydrogen power. Since its founding in 2003, Tesla has established itself as a global leader in electric vehicles, with Musk driving its mission to improve living standards through cutting-edge technology and sustainability. Through various eco-friendly projects, Tesla has helped shift public perception regarding energy, fuel, and climate change. As the world embraces cleaner energy solutions to combat climate change, electric vehicles are becoming increasingly popular. Tesla's recent decision to explore hydrogen fuel cells raises an important question. How does this technology work, and what advantages does it offer? Traditional vehicles contribute significantly to environmental pollution through fuel combustion. Tesla, producing 500,000 electric vehicles annually, has played a key role in promoting the adoption of electric cars. These vehicles primarily rely on batteries that store electricity sourced from charging stations. However, long charging times, range limitations, and high costs have deterred some potential buyers. Hydrogen fuel cells have emerged as a promising alternative, addressing many of these concerns. Unlike battery electric vehicles, hydrogen fuel cells generate electricity on demand through a process called reverse electrolysis. Hydrogen from the fuel tank reacts with oxygen, producing electricity while emitting only water vapor. Unlike traditional EV batteries, which require external charging, fuel cells continuously recharge themselves, ensuring a consistent energy supply. When hydrogen is produced using renewable sources, the process has a minimal carbon footprint. Beyond environmental benefits, hydrogen fuel cell vehicles offer a unique driving experience. They are quieter than traditional cars and even more silent than regular electric vehicles. Additionally, they have a significant advantage when it comes to refueling. While battery electric vehicles take hours to charge, hydrogen-powered cars can be refueled in minutes, similar to conventional gasoline vehicles. This feature, along with the high energy density of hydrogen, allows fuel cell vehicles to achieve a greater driving range than many electric cars. Tesla's Model H, set to launch in 2024, will showcase these advancements. This hydrogen-powered vehicle promises cutting-edge performance, including an acceleration time of just 1.2 seconds from 0 to 60 mph and a driving range of 450 kilometers. However, hydrogen cars currently face challenges such as high production costs and limited refueling infrastructure. Industry experts predict that these obstacles will be addressed within the next decade as more automakers invest in hydrogen technology. Tesla plans to follow up with additional hydrogen models, including the Model 2 in 2025 and Model Z in 2027, both of which are expected to be high-performance vehicles. Despite Musk's initial skepticism about hydrogen, other major automakers such as Toyota, Hyundai, and smaller companies like Riversimple have actively pursued hydrogen-powered cars. The debate over the feasibility of hydrogen fuel cells continues among industry leaders. Volkswagen CEO Herbert Diess, for instance, has argued that hydrogen is better suited for heavy industries rather than passenger cars due to cost, inefficiency, and logistical challenges. Musk has frequently dismissed hydrogen fuel cells, going as far as calling them fool cells in a series of tweets in 2020. His opposition is based on key differences between battery electric vehicles and hydrogen fuel cell vehicles. While both use electric motors, Battery electric vehicles rely on externally charged batteries, whereas fuel cell vehicles generate electricity using hydrogen. The U.S. Environmental Protection Agency, EPA, describes fuel cell electric vehicles as similar to traditional EVs but with an onboard electricity generation system. The global automotive industry remains divided on the future of hydrogen-powered cars. BMW recently announced tests of vehicles with hydrogen fuel cell drivetrains, viewing them as complementary to combustion engines, hybrid systems, and battery electric vehicles. While hydrogen is gaining attention, fuel cell electric vehicles still represent a small share of overall car sales. Toyota believes hydrogen has applications beyond cars, including heating, lighting, and industrial use. The Fuel Cell and Hydrogen Energy Association supports this perspective, emphasizing hydrogen's long-range potential, quick refueling, and environmental benefits. Beyond passenger vehicles, hydrogen fuel cells are being explored for larger transportation modes. Trucks, buses, trains, and even airplanes are being considered for hydrogen power. Daimler Truck's CEO Martin Damm believes that hydrogen fuel cells may be more practical than batteries for long-distance transportation. The European company Alstom has already introduced the world's first hydrogen-powered passenger train, and plans for commercial hydrogen electric flights are set for 2024. Additionally, construction equipment manufacturers like JCB have developed hydrogen-powered excavators, demonstrating the technology's adaptability across various industries. Despite its potential, hydrogen fuel cell technology faces hurdles, including production costs, infrastructure limitations, and reliability concerns. Honda's recent decision to halt production of its Clarity fuel cell vehicle highlights these challenges. However, as the urgency to adopt sustainable energy solutions grows, hydrogen fuel cell technology may play a crucial role in shaping the future of transportation. One of the major obstacles to the widespread adoption of fuel cell vehicles is the current lack of infrastructure. The limited availability of hydrogen refueling stations significantly hampers their expansion. Additionally, the competitive landscape presents further challenges as green hydrogen, produced from renewable sources, not only competes with hydrogen derived from fossil fuels, but also faces stiff competition from conventional fuels like petrol, diesel, and electricity. Although hydrogen fuel cell technology holds promise, the road to mass adoption is filled with hurdles. The International Energy Agency's Global EV Outlook 2021 highlights a stark contrast between the number of registered fuel cell electric vehicles and conventional electric vehicles, further emphasizing the impact of infrastructure limitations. Discussions on social media have brought forward mixed reactions regarding these developments. Some users have questioned Elon Musk's stance, as he has previously dismissed hydrogen-powered vehicles but now appears to be shifting his views. This change has led to skepticism, with critics pointing out contradictions in his approach. Until more details emerge, many remain uncertain about Musk's potential involvement in this space. The conversation has also expanded to ammonia engines, with some enthusiasts advocating for their potential superiority over traditional combustion engines due to ammonia's higher energy density compared to hydrogen gas. Beyond range advantages, ammonia offers an environmentally friendly alternative to gasoline and diesel, as it can be sustainably produced from renewable sources. However, analysts express doubts about its viability, citing major challenges such as the lack of refueling infrastructure, safety concerns, risks of accidents, and the high energy costs associated with production. Since ammonia-powered vehicles are still in the early stages of discussion and development, their long-term potential remains uncertain. While battery electric vehicles currently dominate the transition toward low-emission transportation, the path forward is anything but straightforward. The intense competition in the industry extends beyond vehicle manufacturing, as evident in the ongoing rivalry between Tesla and Apple. Drawing parallels to the competition between Apple and Google, Musk has noted that while Google has demonstrated impressive advancements in autonomous transport, it is not a car manufacturer. Instead, Google's approach involves licensing its technology to established automotive companies, such as Fiat. Musk has also commented on Apple's entry into the autonomous vehicle space, suggesting that an earlier start could have been more beneficial for both Tesla and the industry. He acknowledges Apple's potential, though he believes large-scale production may not take place until after 2020 at the earliest. Despite some skepticism regarding Apple's timeline, Musk remains optimistic about its success and recognizes the broader significance of multiple major players contributing to advancements in transportation technology. Tesla's role in reshaping the automotive industry extends beyond electric vehicle production. Musk has emphasized that the company's various divisions, such as the supercharger network, could each function as independent Fortune 500 companies. He also highlights Tesla's achievements in the U.S. electric vehicle market, where it sells more EVs than all other manufacturers combined. Musk boldly claims that Tesla has done more for the environment than any other company, pointing to its large-scale impact on reducing emissions. Despite Tesla's significant contributions, the company has faced challenges in the political and regulatory landscape. Musk has recalled incidents where Tesla was excluded from key industry discussions, such as an electric vehicle summit at the White House, despite leading the sector in production. Frustrations peaked when President Biden credited GM with spearheading the EV revolution, despite Tesla producing 300,000 electric cars in the same quarter that GM managed only 26. Musk has also addressed regulatory matters, noting that while Tesla adheres to the vast majority of legal requirements, occasional disagreements arise, such as the insistence on coming to a full stop at every stop sign, even in situations where it may not be necessary. Nonetheless, he acknowledges the National Highway Traffic Safety Administration's NHTSA generally reasonable approach to evaluating automotive safety. The future of transportation, according to Musk, is undoubtedly electric. He likens companies that fail to invest in EVs to horse-drawn carriage manufacturers who resisted the transition to automobiles in the 1920s. Holding on to outdated technologies, he argues, is a path to obsolescence. Musk has also emphasized Tesla's innovative advancements, particularly in manufacturing and vehicle design. One notable development is Tesla's use of steer-by-wire technology, which eliminates the traditional mechanical connection between the steering wheel and the wheels. Instead, it functions similarly to modern jet airliners, where pilot inputs are processed by a computer rather than being physically linked to the control surfaces. This allows for dynamic adjustments, making steering more responsive at low speeds while reducing sensitivity at high speeds, thereby improving the overall driving experience. With ongoing advancements in alternative fuels, autonomous technology, and electric mobility, the future of transportation is evolving rapidly. As new developments emerge, the question remains: will hydrogen, ammonia, or electric power dominate the landscape? What are your thoughts on this shift? Share your opinions in the comments below.